Okay, here's a couple of word type problems that you might get asked to solve, along with a little technique for dealing with isosceles triangles. So I'll start with the isosceles triangle question. The sort of thing you might get asked or useful with isosceles triangles is if I'm given the end and told that the two long sides are equal and both are, I'll stick to nice numbers, are 13 centimetres. On the bottom, I know the base is 10 centimetres. Now, I might want to be able to find out what the area is or find out what the apex height is. So we're going to solve both those problems quite quickly. The first thing to realise is if you take an isosceles triangle, it has a line of symmetry that goes through the apex at the top. And remember the rules of lines of symmetry, they split all angles in half, including when they meet a side. A side is a 180 angle and it splits it in two to give you a 90-degree angle. So now what we can do is we can actually work out how tall this triangle is. So I'm just going to make a quick copy of it and put it over to the side. We know the outside is 13 centimetres because that's equivalent to that one, and we've got half the base. This line of symmetry splits that in half. So we've got a base 5. Well, now we're looking at Pythagoras theorem. We've got a right angled triangle. So let's do my quick relabeling. Start off with the right angle, go to the opposite side. That's your hypotenuse. The other two sides, or the two legs, the Americans call it, go either side of the right angle. Remember Pythagoras theorem, h squared equals a squared plus b squared. The square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay. Stick our numbers in, so everything in green is what I'd expect to see for a question. We've got 13 squared is 5 squared plus, there was no length here, but we've got a perpendicular height or the altitude. Let's call it, I'll call it b. There was nothing given in the question, so b squared. I want the b squared on its own, so I'm going to subtract 5 squared from both sides. That removes this 5 squared from here, effectively dragging it to the other side. This line probably I would not expect to see being written actually, so I'll just raise it. This is a thinking step really, because it's the sort of thing you might do. 13 squared minus 5 squared equals b squared, and we would calculate that. Zoom on, where's my calculator? Oh, there it is. So calculator comes up, I want 13 squared minus 5 squared, and that gives me 144. Now if you remember previous lessons, you don't have to show 144 as b squared. We know we want to find what b is. How do I find b from squaring? You take the square root of both sides. So b is the square root of 144. If you didn't know, square root of 144 is 12 centimetres. I chose quite a nice question there. So the sorts of things you might get asked is, what's the apex height? The perpendicular height, actually 12 centimetres. Or, what's the area of that triangle? So the area of the triangle now is 1/2 the base times the height. In fact, I'll do that in blue because I won't necessarily expect to see the formula. I want to see that the formula is being used properly. Base times height. Base is 10 centimetres, so 1/2. The base is 10 centimetres times my perpendicular height, which is 12 centimetres. So I've got 5 times 12, which is 60 centimetres squared because it's an area. I'm not sure that you believe me. Let's do 1 divided by 2. Actually, cancel that a minute. Let's just check the square root of 144 is 12, correct. Now we're going to take that answer and we're going to do 1/2 times 10, the base of the isosceles triangle, and times the perpendicular height, the one I've just calculated, and that gives me my answer 60. So that's a fairly common type question. What's the area on the end? Now if you remember, because of that, we can now actually do what I call the Toblerone box and find its volume. The volume of that is going to have 10 at the bottom, and we know the apex at the top is 12 centimeters, and if this is 15 centimeters long, the volume of that sphere, that prism, is going to be area of the cross section, 60 centimeters squared, times by the length, 15 centimeters, and that is going to give me 900 centimeters cubed. So there's my 60 on the end. I'm going to multiply that by 15 to give me the volume of the prism. 900 centimeters, centimeters squared by centimeters, centimeters cubed. That's also the same as cubic centimeters or milliliters. So this box is 0.9 of a litre. Okay, just a little side on some units. So that's the first sort of thing you might get asked, is what's the height of isosceles triangles. I'll give you some other situations that they do and how Pythagoras worked with them. So we'll go on to the first type of situation. Right, so the sort of thing that you get told is questions like ship, yes, sails, perhaps if we use the right sort of sail, sails 50 kilometers north, then 40 kilometers east from port. How far is it? Port. So how far is it from the port? So let's start off with the ship. It begins at the port P. It goes north, so always upwards 50 kilometers. Remember our bearings: north, south, west, east. So it then goes east 40 kilometers to get to the new position for the ship. And they want to know how long is this distance between the two. So 50 kilometers north, 40 kilometers east, and we're now going into doing Pythagoras. So the first thing I probably would say is you need to draw the diagram. So really, if you've been given it purely as words, draw the diagram. That's your first step. Second step, doesn't matter if you do it properly or not, right angle is between the north and the east. So we've got a hypotenuse, which is the line SP. I'll be talking about SP as the length again. And we've got A and B, our two sides. Remember Pythagoras, h squared equals a squared plus b squared. And then we put our values in. So we want the distance h squared, which if you remember from yesterday's lesson, the length of SP can be written as two lines either side of the ends of the line. Squared is A, 40 squared plus 50 squared kilometers. So let's come down, use the calculator. I want to get 40 squared plus 50 squared. Oh, helps if I'm on. 40 squared plus 50 squared gives me 4,100. You've seen me do this a lot of times now. I don't want to put write a separate line saying do the square root, so I'm going to do the square root of SP squared. and do the square root of the right hand side. Square root opposite of squaring. So do the square root of my answer, and that gives me 64.031 kilometres. That's actually 64 kilometres and 31 metres. For most questions like this, one decimal place would be sufficient. That's the first question. Simple bearings questions, they're quite common. You can sometimes be told how far away you are, and you've got to work out how far up and down it went from north and east. But they're all playing about with making the description. Next situation is a ladder. Okay, so this is the situation. I'll just scroll it so it's the top of the screen. A ladder rests against the wall. The ladder is 15 metres long and the foot is 5 metres from the foot of the wall. How far up the wall does the ladder reach? Now, some people quite quickly turn around and say, oh, it can only be 10 metres. We're going to show that that's not true. Now, this bit about to the nearest centimetre, we'll deal with that at the end when we're doing rounding. But the first thing to do, always, so I'm doing it in green, is draw the diagram. So we've got a ladder, which is essentially we're going to say is a straight line. It goes to the wall, and we know our ladder is 15 metres tall, long. So we know how long it is. The foot, we're going to assume the floor is level, so we get a right angle at the corner, and that is 5 metres from the end. Okay. So the question is, how far have we reached up the wall? How far high is it? We call that y. So usual thing, run through the question. We've got a hypotenuse, we've got adjacent, and we've got a side b. So we've got h squared equals a squared plus b squared. You do not need to worry about writing that every time. I just do it to reinforce. Put the numbers in. We've got 15 squared is equal to a is 5 squared plus my length y. Seeing that is enough for me to give the mark to show that you understood using Pythagoras. Okay, so these questions are often worth 2 or 3 marks. This is probably worth maybe 3, and that's your first mark is the diagram, second mark is the Pythagoras, and then rearranging to solve will give you your third mark. We want the y bit on its own, so y squared is 15 squared, and I've got to take 5 squared from both sides. Drag it across the other side, change the sign. Bring up our calculator, do the sum. 15 squared minus 5 squared gives me 200. Seen me do this a lot of times before. Jumping from the y squared, I want to do the square root of both sides to give me the y. So the length y is the square root of 200. So I do square root of my answer, and I get an answer of 14.142135. This last part, some of you may have worked in centimetres anyway. To the nearest centimetre does not have to mean the answer's been given in centimetres. What it can mean is I just want to know what is in the centimetre place. Well, centimetre is, there's 100 centimetres in 1 metre. That means that I want the second decimal place to find 1 centimetre. Look at the 2 says round down, so we only need the 4. So my distance here is 14.14 metres. That is perfectly acceptable to give it to the nearest centimetre. They didn't explicitly say I needed to give my answer in metres, but I needed to give it to that accuracy. And we know I need to do 14 meters and 14 centimeters. Okay, do one more. Okay, so we've got a new situation coming in. Between two buildings, electrical cable is going to be installed between the tops of the walls. We know that the two buildings are 36 metres and 29 metres tall each, and that the relevant walls are 15 metres apart. Now, to be able to calculate the correct cable length, the company must know what is the shortest distance between these 2 points. The reason this question is worded this way is if you know anything about installing metal and what happens to metal in cold weather, the cable manufacturer has given them some leeway. When things get cold, metal shrinks, particularly over cables. If you have a look at the electrical cables you see around, during the winter they can be quite flat, very little, and then right at the height of summer they will droop a very long way. And the difference is quite important. So this cable manufacturer said that at the end we need to add a 5% on for cold weather shrinkage. So let's go through the question, try and sort it. So what I first need to do is draw a diagram. And we've got our first building here, which is 29 metres tall. Second one is 36 metres tall. And between got 15 metres. Now the shortest distance is from the top of those 2 points. So that is the shortest distance we need to know. Okay, what I was talking about, I'll show you when we do this bit what happens with the cable. So we actually need to look, first of all, where is my right angle triangle? Well, the right angle triangle has a base along that side. And assuming that the walls are perpendicular to the base, it goes up that side and we now get our right angle triangle. The length along the bottom here is 15 metres, and we need to know how much taller is the tall building than the short building. And in this case it is 7 metres taller. So let's label that in because those numbers should be included. I'll just clean those up because you can't read that easily. So we need 15 metres along the bottom, we need 7 metres going up the side, we don't need the 36 and the 29 anymore, and the distance we want is this one, so that's C for cable length. C is opposite my right angle, so my hypotenuse. It doesn't matter about the other two, which way round they are, they're both the legs on the right angle, which ways come away. So stick the numbers in, or let's write the formula just to remind you. H squared equals A squared plus B squared. If anyone tries to tell you to use C squared, ask them how do they know the difference between hypotenuse and another side. And that's why I use H. H is the hypotenuse. From my diagram, H is C, so C squared, A is 15 squared, so this one is working out. Actually is a very nice simple problem. Use the calculator to calculate the squares. 15 squared plus 7 squared, and that's 274. Hopefully you all get used to what happens next. I'm going to do the square root of both sides. So that changes to C, and I want to do the square root of my previous answer. So my C length is the square root of that answer, which is 16.55. Now I would say we need at least the nearest centimetre in this. 16.55 metres. So I'll just finish off the problem. The cable manufacturer says the cables should allow 5% for cold weather shrinkage and installation, so you lose some during installation as well. How much cable must be ordered? So I missed out ordered. I typed it. So I'm going to do that calculation now. So we have start, change, end. We start with 100 meters, 100%. Meters is the distance. Change is add 5. End is 105 then. By 16.55, we are trying to build on 5% from it. That is my 100%. And my question is, how long is the end? So I write my equivalent fractions. The x is my first thing. Its partner distance in meters is 16.55. Write the other equivalent fraction on the other side. Partner to x in that direction is 105. And the start was 100. So to get my x, multiply both sides by 16.55 to give me my new length. So I'll take my calculator. It doesn't matter how you get to doing this 105. Some of you might recognise that as a decimal of 1.05. I'm going to put it in as shown. So it's 105 divided by 100. And I've already multiplied by my answer. And that says I need to order 17.38 meters of cable for that job. That means it's a little bit too long, and what will happen is you'll get, most of the time, you'll get some droop. As it gets hotter, it droops more. When it gets colder, it gets closer to that line. Okay, so some word questions set up on it for you. Have a go at them. The word answers are also available. I am interested in seeing the diagram and your calculations. Everything you see in green is what I am expected to see in your questions. Okay, good luck with that.